Now I'm actually re-recording this for some strange reason. The original recording that I did didn't work out. So this is actually the start of the answer series for the worksheet on kinematics. By now you should already have done it. I would have already marked it somewhat. So this is for you to kind of check your answers and kind of find out where you went wrong if you did. Okay, so the answers are already written. Like I said, I actually already pre-recorded one, but that video didn't work out. So let's see and hope that this one works out. Okay, so question number 1, the velocity of a car increased from rest to 25. So I'm gonna highlight certain things from rest to 25 in 5 seconds. So these are kind of the information that I need to find the acceleration. So I'm going to apply this formula, a equals v minus u over t. The final speed, the final was 25. Initially, it was at rest, so it's 0. And the time that it took was 5 seconds. So to find the acceleration, I employ this formula, put in all these values, and I get the answer of 5 meters per second. Okay, next. It is already moving at 30. Okay, I apologize. Many things going on right now. I think my computer was processing the previous video. Okay, so right, where were we? A car moving already at 30 meters. So this is the initially, it was moving at 30. It came to a rest. So finally it stopped in 3 seconds. Yeah. So therefore, initially was a U, came to a rest is the final, and a time 3 seconds. All right. So I am going to stick with this formula, a equals to v minus u over t, even though they want me to calculate the deceleration. And I realized that I ended up with a negative answer. So here's where you have to take note. A negative acceleration is actually a positive deceleration. Okay, so I have to rewrite sort of like a final statement answer to state that the deceleration is 10 meters per second squared. Okay, so let's look at part 2, question 2. So I've got a speed time graph, very, very common. You have to learn how to interpret a speed time graph of a car. Now calculate the acceleration between A and B, So same thing, I'm going to use this formula, a equals to v minus u over t. The final speed is 14 from here to here. Final speed is 14. Initially, u started at 0, okay, and the time that it took is 3 seconds. So you press your calculator, 14 minus 0 over 3, you get 4.67 meters per second squared. Calculate the deceleration for part B. So I'm looking here. This is where it decelerates between B and C. Same thing. I'm going to use a equals to v minus u over t. The final speed is 0 now. Initially, it was at 14, goes to 0, and the time that it took is not 8. It is this interval, which is 5 seconds. 8 minus 3, which is 5. So again, I end up with a negative answer. Not surprising. So I have to kind of rewrite a statement. A negative acceleration is equals to a positive deceleration. That's how I end up with 2.8. Okay, distance traveled. So to calculate the distance traveled, I have to employ this formula. Distance traveled is the area under the graph in 8 seconds. So the area under this whole graph, the area here is in the shape of a triangle. Yeah, it's in the shape of a triangle. And therefore, I use half times base times height. Half times base is 8. The base is 8. And the height is 14. Okay, equals to 56 meters. All right, so I think this is where I stopped the previous recording, and I'm gonna edit in the second video after this. So see you later.